Hello, everyone. We're going to get started. So today I'm going to be talking about XAPI and also a little bit about associative dimensions. So first things first, going to go over our itinerary here. So as I said, we're going to start off by talking about XAPI. That's been the main focus of this presentation. But we are going to talk a little bit about associative dimensions. And so we're going to first go through on what is XAPI. When is it useful, how to use it, performance of using it, any helpful tips, and then from there I'm going to diverge and talk a little bit about associative dimensions, and then I'm going to come back around and go in depth on how XAPI works in the backend. All right, so to begin, what is XAPI? XAPI is a new way to call methods on prop objects without casting the object. You can think of it as prop defs for methods, but they work a little bit differently, and they're also set up differently. So there are a few new methods on the prop object class, and just like prop defs, we have a syntax for actually defining the XAPI defs. When is it useful to use XAPI? XAPI is very nice for situations where you would do a lot of casting to call methods on objects that all implement the same functionality but don't necessarily share a common base class. One case for this would be with getting your DSP data from any object without casting. We can see here on the right, the top code block is how a function like this may look today, having to cast the core object we're passing in as all of our different database classes and getting our data there, just basically calling the same method. The bottom there is what that all can be condensed down to using XAPI. So how do we actually use XAPI? The easiest way to implement XAPI is to use the syntax. Just like the propdef syntax, this syntax will add all of your XAPI defs to your object. Once the XAPI defs are defined for your object, you can then call xrun on any object of the class, providing the key of the def, which is most likely the method name, and any parameters for that method. And just like the get method that's on prop object, xrun returns a generic object, so anything that gets returned from an xrun call, you'll need to cast. And when xrun gets executed, if there are any issues finding the def, an error will be printed out. Some typical errors that could be printed out are going to be an unknown def error, where it didn't find the def that you passed in with the key and the parameters, or you may get an ambiguous def error where it found multiple defs that it could call. Just like with methods, you may have an ambiguous method call as well. So on the right here, we have a little test class showing how to implement, how to use the syntax. So you can see there at the top, we have public XAPI, and then that code block, we have what looks like just method, setting up methods there. And that's pretty much it. So you can see I have a few methods in the class. A couple things to note with the syntax. You can see that I have two of these that are called test1 that take in different objects. So test1 in this case would be the key for the XAPI def. But you can see I have to the right there, each of them say equal. One of them says test4, the other one says test5. That's the actual method it's going to call. So you can see in my class, I have a test4 method that takes in a prop object, and I have a test5 method that takes in a string. So we'll see here in the next slide, when I call test1, if I pass in a string, it'll actually call test5. If I call test1 and pass in a prop object, it'll call test4. And so talk a little bit about the performance of XAPI real quick. So the previous way to call a method without casting was to use the method call syntax. Although the method call syntax works well and has been improved over the past couple of years, it does have a higher performance cost compared to XAPI. And so on the right here, you can see me actually creating the myObject class from the last slide, calling xrun to call those methods. And you can see here I'm calling test1 twice. One of them I'm passing in a snapper, which extends a prop object. The other one I'm passing in a string to kind of show that based on those parameters, it will find and call the correct one. And then you can see under that, I have some, I'm using the p-time syntax there to print out the performance and to gather that. So when running the code on the right, doing 10,000 calls to method call and doing 10,000 runs with xrun, and doing that about 5 times each, method call averaged about 50.770 milliseconds per call, whereas XAPI averaged about 16.275 milliseconds. So quite a bit faster to use XAPI over method call. So I'm going to give a couple little helpful tips on XAPI and from what I've seen using it. So thing to be aware of is that the XAPI defs, they get cached the first time you call xrun. So as you're developing, if you're adding more defs and xrun has already been called, it won't be able to find those defs. So from there, you need to clear out the cache. This can be done pretty easily by calling xclear on the object or by directly calling the XAPI manager and the clear method on that and passing in the class that you want to clear the cache for. Also, the XAPI syntax doesn't support using a custom key, at least not quite as nicely as the propdef syntax does. You can still pass in a constant key when you're using xrun, and it can be really helpful to create those to kind of help manage where you are using XAPI and to also make maintenance a little bit easier if you need to update that XAPI def and where you're calling it. Okay, so I'm going to real quick talk a little bit about associative dimensions, and then I'm going to dive into more in-depthly how XAPI works and what calling xrun does. So associative dimensions are dimensions that are actually linked to snappers and will update when a snapper moves. So this will make dimensioning a project a lot easier for the users by reducing their need to actually update these dimensions or to delete and recreate them. So currently they work by using snapper refs to keep track of the snappers that are at each end of the syntax, or excuse me, at each end of the dimension. And when those snappers get a call to dropped, it will then find the dimensions that it is linked to and update those dimensions. So the current system is using XAPI to define the locations that these dimensions can more or less connect to. They're kind of like feature snap positions. But there are some functions in core that will automatically generate these locations for you based on either the bound of your snapper or a path. And this functionality is still being worked on. So that may change in the future. But because it's currently using XAPI, it would be an opt-in feature for your snappers. But I talked with some of the devs working on it, and they ideally wanted to not be opt-in. They wanted to be functionality that more or less comes in for free on your snappers and where you could tweak it as you need be. So keep an eye on that. I believe it's currently looking to be released, I believe 11.5. Last I spoke with the developers on the project. Okay, so now I'm gonna get a little bit more in depth on how the XAPI actually works. So first things first, when you call xrun on a prop object, it will call run on the XAPI def manager, passing in the key and parameters of the xrun call. The run method will call get on the XAPI manager to find the appropriate def, and then it will try to call run on that def. In order to find the def, it first will gather and cache all the XAPI defs for the class on the first XRun call, and it will then try to get the correct XAPI defs object based on the key passed in. It will then call get on the XAPI defs object and return a XAPI def entry object. And once it has that object, it will then call get on that object. Once it calls get on that object, it will create a prop obj heap made up of XAPI defs match entry objects. So the prop object heap object is a binary heap of all the individual XAPI def objects with the same key sorted by some aspects of the def and the parameters passed into XRun. The heap will prefer defs that require the least amount of casting of parameters, then the greatest number of required parameters, and finally the greatest number of parameters in general for each of the defs. Once it has found a valid def, it will then call run on that def. The code that is actually in run on the actual def gets implemented by the XAPI syntax. So the syntax is going to make a private class for each def based on the key and the source reference position of the string passed in. This class will get the run and the default values methods implemented. If the method doesn't have a return type, albeit a void method, it will return true by default. And here on the right, we can see the actual code that gets put into those methods. So on the top, we have run, and on the bottom there, we have default values. So we can see what the syntax is actually doing here is it's getting the object, it's overriding the local this parameter on the method, then it is directly calling the method that was passed in with the parameters and then returning the object. So it actually is kind of sneakily calling the method there. And I know that was a lot of info kind of all at once. I have the rest of the time here for any questions. So if anyone has any questions or anything like that, feel free to post in the chat or to speak up. Or if there are no questions, that will be it for this session. If there are any questions after the fact, feel free to post them in the briefcase relating to the class. I'll try to go through and answer any questions that come up there. Otherwise, thank you all for your time. Hope you have a wonderful day.